In our lesson today, we're going to learn about one-step inequalities. So this is very, very similar to one-step equations. The difference is instead of using an equal sign, we are going to focus on the symbols we've been talking about the past couple days, the greater than symbol, the less than symbol, the greater than and equal to symbol, and the less than and equal to symbol. So solving one-step inequalities is identical to solving one-step equations, except we're going to be focusing on these symbols instead. So just to review very quickly before we get into how to solve one-step inequalities, let's just review a little bit about inequalities. So remember, inequalities, if we wrote something like this, x is greater than 4. What we are saying here is that any number that we put in for x has to be greater than 4. So with inequalities, you can have more than one correct answer. We could put in 7, we could put in 10, we could put in 1,000,000. We could even put in 4.5. We could put in 4.3. Any of these numbers would work for x as long as they are greater than 4. Then we learned a little bit about the inequality signs with the equal to sign underneath. So if we had x is greater than or equal to 4, not only can we include all of these numbers as a solution for x, but we can now include the number 4 as well, because this little line underneath our inequality says that x can also equal 4. So what we're going to be doing today is the same kind of thing as what we did the past couple days with, just looking at inequalities and deciding what the solutions are going to be and putting them on a number line. But we're going to have to do some one-step problems involved with it, which we have not done yet. So you guys will see what I mean when you look at the next slide. So solving one-step inequalities, you do it the same exact way you would solve one-step equations. And remember, an equation uses an equal sign, and inequalities are using the greater than and the less than, the greater than and equal to, and the less than and equal to signs. So the process and the steps are identical. It's the symbol in between the quantities that you have that is changing. So I'm going to go ahead and show you a few examples that have already been done. Please make sure you have paper and pencil ready to go and you are writing these down and doing them with me. So you see that we have this inequality n minus 8 is less than 15. Okay, and we say less than because remember this little Pac-Man guy or your alligator, however you want to look at it, always wants to eat the larger amount. And so in this case, it is 15. So whatever the n minus 8 is over here is going to be less than 15. But let's just pretend for a second that this was n minus 8 is equal to 15. We would do the same process over here with an equal sign as we do with inequality signs. So if this was an equal sign, we would have to do the inverse operations to get rid of whatever is with n so we can get n by itself. So in this case, we're subtracting subtracting an 8, so we need to add 8. On the left side, or the right side, we need to do the same thing, add 8. Well, if you look over here, they did that. We have minus 8, so they did the inverse and added 8. And whatever you do to the left, you need to do to the right. So they did 15 plus 8. Well, you get n by yourself, and you get that 15 plus 8 is 23. The same thing would happen over here. These would cancel, n is by itself, and this would just equal 23. So n would have to be 23 within an equation. But over here with inequalities, we're talking that n could be anything as long as it's less than 23. But the process itself is identical. Here's another example that has already been done for you. So it says 13 is greater than or equal to a plus 7. And just to review, Pac-Man guy always wants to eat the most, right? He has his mouth open towards the 13, meaning that is a larger amount than whatever a plus 7 is. The little line underneath our inequality means or equal to. So 13 is greater than or equal to a plus 7. Well, we want to know what a is. So we do the same process as we would do for an equation, but this time we just have an inequality. Over here, A is being added with 7. So since we're adding 7, we had to take away 7 or do the inverse operation to get rid of it, which means we have to do the same thing over here. Whatever we do to one side, we have to do to the other. These cancel, they go away, they become 0, and 13 minus 7 is 6. The difference is we don't have an equal sign here. We keep our greater than or equal to sign. So your answer is that 6 is greater than or equal to A. Same thing with our division and our multiplication. Inverse operations to solve to get the variable by itself. So as you can see over here, and I'm actually going to redo this one just because it's kind of off to the side. So we have 3x is greater than 24. Again, our inequality sign is open towards the 3x. So whatever this amount is, it's going to be more than 24. But the thing is, we're doing 3 times x right now. Remember, when you have your coefficient and your variable next to each other, you are multiplying. We just don't always write that little dot there. So in order to get rid of this 3 that we are multiplying by the x, we have to divide by 3. So I'm going to go ahead and divide by 3. Whatever we do to one side, we need to do to the other. So I'm going to divide by 3 over here as well. 3 divided by 3 is just 1. So these cancel and you're just left with x. And over here, 24 divided by 3 is 8. And I'm not quite sure why she has a negative 8 here. So it's not negative, it's positive. So greater than 8. And our last example we're going to do that has already been done for you and just kind of explaining it is the reverse, when we have multiplication and we're going to divide. So this is written kind of funny as well. So I'm just going to go ahead and rewrite it over here. So what this should say is A divided by 2, remember our fraction bar is the same as a division bar, is less than or equal to 8. Okay. Well, if we're trying to get A by itself, currently A is being divided by 2. So what is the inverse operation of division? It's multiplication. So I'm going to multiply this side by 2. And whatever I do to one side, I need to do to the other. So that means I need to do 8 times 2. Well, these cancel because they equal 1, and you're left with A, which is less than or equal to 8 times 2, which is 16. So as you can see through the last 3 or 4 examples that we did, the process that we've been doing to solve equations is identical to the process of solving inequalities. The big difference is instead of an equal sign, you have these inequality signs. So here is where, can you please write down 10 is greater than or equal to x minus 1 on your paper. I want to make sure you guys are doing this with me. So what we want to do is we want to solve this inequality. And the only way we can actually solve it is to get x by itself, because we don't know what x is, so we just have to leave it as x. We don't have a number to put in there. But what we can do is solve for x and then put it on the graph. So the first thing I'm going to do is I'm going to say, well, what's happening to x? I'm subtracting 1. So in order to get rid of it, I need to do the inverse, and I have to add 1. Whatever I do to one side, I need to do to the other. So I need to add 1 over here. Negative 1 and positive 1 becomes 0, so you're just left with x. And 10 plus 1 becomes 11. And in the middle here, we still need that greater than or equal to sign. So the inequality that you're going to put on the graph is 11 is greater than or equal to x. Now, you will notice that these number lines that we're going to use today look a little different than the ones that we did on Monday for our virtual Monday. They don't have tick marks and they don't have numbers. But trust me, this will be very simple and you don't want to overcomplicate this process. Number lines have arrows on either side of them to show you that they go on forever in both directions. So we're just going to put the numbers that we need to show this inequality And then the arrows are telling us how it goes on forever in either direction. So here's what I mean. 11 is a number that we know. 11 is a number that we can start with on our number line. So right here in the middle, I'm going to go ahead and just make that 11. Then I'm going to make 2 tick marks that show 2 numbers larger than 11. So 12 and 13. Then I'm going to make the 2 tick marks below 11. So that would be 10 and 9. So do you guys see how we still just have like this mini number line, and we have a couple numbers to the left and to the right of 11 to just show greater than or less than. So here we go. Now we're going to go ahead and put our inequality or graph our inequality on the number line. So we know we're going to start at 11. And the question is, are we going to have an open circle? Or are we going to have a closed circle? And because of this equal to bar underneath our inequality, the circle at 11 is going to be closed. We want to include that as part of our answer. So you're going to fill it in. Now, it's saying that 11 is greater than any number that we would put in for x, okay? The Pac-Man wants to eat the 11. So that means any number we put in for x has to be less than 11. So I'm going to shade this direction to show all the numbers that would be less than or equal to 11. And that is how you would graph this inequality on a number line. You can always check yourself by plugging in a couple of these numbers that you shaded. So if I do 11 is greater than or equal to 9, does that remain true? Yes. Is 11 greater than or equal to 10? Yes. So I know I shaded in the correct direction. Make sure you write this example on your paper. Do this one with me as well. So we have 5 plus h is less than 7. Well, I want to try to get h by itself. So if 5 is being added to h, let me make that a little more clear, then I'm going to go ahead and subtract 5. Whatever I do to one side of my inequality, I need to do to the other side of my inequality. These 5s cancel, leaving me with h, which is less than 7 minus 5, which is 2. So now I have this inequality, h is less than 2, and I need to put it on my graph or my number line. Again, let's make this number line simple. I know that I'm going to have to put a dot at 2, so I'm going to make that my center number, 2. I'm going to pick 2 numbers greater than 2, so we'll do 3, 4. 2 numbers less than 2, so we have 1 and we have 0. Next question is, am I going to have a filled in dot at the 2, or am I going to have an open dot or circle at the 2? And this time it's going to be open because I don't have a line under here saying that it's equal to 2. So I don't want to include it in my solution set. So it's going to be open. And now it says every number h has to be less than 2 because Pac-Man, again, he's wanting to eat the 2, which means anything we put in h has to be less. So we would shade in this direction, including the arrow to show it goes on forever. In this example, we are saying that 7 times p is less than or equal to 42. Remember, when you have your coefficient 7 and your variable p next to each other, you are multiplying. So how do I undo the multiplication problem? I have to divide or do the inverse. So divide by 7. What do I need to do to the right side? Divide by 7. 7 divided by 7 cancels, becomes 1, so you're left with p, which is less than or equal to 42 divided by 7, which is 6. Now let's go ahead, graph this inequality on the number line. Well, we know we're going to start at 6, so let's make that our center number. 2 numbers larger than 6 are 7 and 8. 2 numbers smaller than 6 are 5 and 4. Will our circle be opened or closed? Well, it will be closed because we have the equal to bar underneath our inequality. So 6 is going to have a closed circle. P is any number less than or equal to 6, so shading to the left is going to show every number less than or equal to 6. Our last example we're going to do together today is this one. Then I want you guys to go ahead and get on the pair deck that I attached to your Google Classroom and do some practice on your own. I will be checking those pair decks to see how we're doing. So when we do meet for class, I can go over anything where people might be struggling or just need some extra practice. So the last example on here is that n over 6 is greater than 2. Remember, n over 6 is the same as n divided by 6. If I want to get n by itself, I have to do the inverse of division, which is multiplication. So I'm going to multiply this side by 6, and I'm going to multiply this side by 6. These guys cancel. You're left with n is greater than 2 times 6 is 12. On our number line, we know we're going to start at 12, so let's make our middle line the 12. 2 larger than 12 is 13 and 14. 2 less than 12 is 11 and 10. Looking at my dot for 12 or my circle for 12, it's going to be open because I don't have an equal to sign under the inequality. Ooh. Sorry, that needs to be open circle. And when we're saying n is greater than 12, so again, looking at this little Pac-Man guy, he wants to eat n, which is any number that's going to be greater than 12. So to show any number greater than 12, we shade to the right, including the arrow. Again, we can always check our answer by saying, okay, 13, is that greater than 12? Yes. 14, is that greater than 12? Yes. So we know we shaded in the correct direction. I want you to go ahead now and click on the pair deck that I put in your Google Classroom stream. Go through it at your own pace and try to work on shading the number lines and solving the one-step inequalities.